Okay, so let's think about this second case. First, I want you to notice that we only have 6 pairs of data. This is very small. The sample size is small, which means what kind of distribution should we be using? T distribution. Okay? We need to use T distribution. Another thing is that the corresponding samples have some kind of a correlation, right? People who have big catches, many number of fish, tend to also have big number in both cases, small or small. And this is somewhat expected because different people have different fishing skills, and also depending on the places they were fishing at, they might have more fish going nearby and stuff like that. So you can kind of expect that the two things are correlated. And therefore, even though we're still trying to compare the two mean values, this is a completely different situation because first the sample size is small, and there is definitely some kind of a correlation between the two data. Okay? In such a case, what do we do? Well, in such a case, we can just develop a new random variable, which is the difference of two. So we're going to define D as just the, let's say, y minus x, or x minus y. So this, I'm going to call this as x, that's going to be my y. So I want to show that D is positive. That's what I want to show. Okay? So let's say D is x, y minus x, and I want to show that this is positive. Then, even if it's correlated, still the difference will be like a bell curve shaped, although this time it's we have to use T distribution. And you're just going to think of this thing as a single value obtained from two values. So you're going to forget that it really was originally two different values, but because it's now paired, from each pair we can get a single value here, so that we can just add an additional column, y minus x. What's our y minus x? This is 2, 4, negative 3, 4, 1, negative 1. Okay? So that's what we have. And we can just use this as our data set, compute the standard deviation. Yes?
Isn't the second one 5?
Oh, thank you, 5. Okay, we can just use this as the data set and just do a regular hypothesis testing. Okay, so let's see how that one works. So step 1, what's our hypothesis? H0. What's the null hypothesis? Null means that the spray is not going to have any effect, right?
So y minus x equals 0.
0, or D is equal to 0.
Yeah.
Y minus x equals 0. Okay?
Yeah.
But I just want to forget that there were even y and x, just that, okay? What's the alternative?
D is greater than 0.
Right, right. We want to show that this is greater than 0, that the scented one is more effective, okay?
So we would use right tail.
This will be right tail. So right tail, so the rejection region will be like this with the right tail, 0.05 on the right side. And for this one, because we're using T distribution, we need the degrees of freedom. What's our degrees of freedom? How many
5.
data points do we have? 6. Right? Degrees of freedom is n minus 1. So this is 6 minus 1, which is 5. Okay? So now what you need to do is you have to do inverse T. Just like we had to use inverse norm, now we have to use inverse T. And for the inverse T, you don't feed in 0.05, you feed in the area left of your rejection region, the boundary of the rejection region.
So 0.95?
Yes, you have to put 0.95. Degrees of freedom is
5.
5. So you put this in. Can you tell me what you get?
2.02.
2.02. Okay, if you round to the nearest hundredths. So that's the rejection region. The value has to be bigger than 2.02 for us to conclude that we have something in the rejection region. Now let's calculate the test statistic. In our case, t is equal to the d bar minus 0 over the sigma over square root of n. But we first have to know the sigma. What's our approximation to sigma? We don't have the true sigma, we just have s, right? The pseudo-corrected one. So what do we do? Well, the quickest one is to just punch these into the list 1, and then you can do one variable statistic, and they'll tell you s of x. Can someone do that? I'll wait. So go to stat, edit, and choose list 1, and just type in 2, 5, -3, 4, 1, -1. Okay. So those with the calculator, please do it now. If you don't have the calculator, please watch someone next to you doing it, because you need to use it. Once you're done, then go to stat and calculate one variable statistics.
Should be 3.011.
You got 3.011.
011.
So you have to be careful. There's a sigma and the s. S is slightly bigger, okay? Because s is the one that's obtained by dividing by 5. Sigma is the one that's obtained by dividing by 6. So s will be bigger. Is that okay? All right. Do I have a second? Who else got this value? Okay, you got that? You got that? All right, good. Yep. Okay, so we have this, and now we can continue to calculate. This should be d bar that we got is, so we have to take the average of this. If you add this, this is 5 plus 5, that's 12 minus 4, this is 8. 8 over 6 is 4/3, 1.333. So we have this as 1.333. Or you can also get the 1.333 from one variable statistics that you just did, okay? You see that? Yep. Minus 0 divided by 3.011 divided by square root of
6.
6. Okay? So that's the value that you have to calculate. Okay. All right, so what's that? And I get only 1.08. Okay, so this wasn't strong enough. So because this does not fall in the rejection region. Do I have a second? Did you get this value as well?
Yeah.
Yeah.
All right. So because this does not fall in the rejection region, number 4, you have to say we failed to reject the null. So the data does not prove, fails to prove that the scent is effective.